Hello, and welcome to a summary on the recent trends in regional rainfall and flooding events across the upper Mississippi Valley. My name is Dan Baumgart. I'm the Science and Operations Officer at the National Weather Service in La Crosse, pictured in the lower left here, and I'll be giving this presentation. I'd also like to acknowledge my contributors, Todd Shea, Jeff Boyne, and the rest of the staff at the National Weather Service in La Crosse. My motivation for this talk and our motivation at the National Weather Service is to help you assess how the rainfall has been changing over the last decades and especially the last few years. There have been a number of regional flooding events that have occurred that have needed and been declared as FEMA disasters, but more closely in the service area for the National Weather Service in La Crosse, there's been also a number of flash flood emergencies or very localized, very heavy rain events in the last few years in northeast Iowa, Wisconsin, and also parts of southeast Minnesota. So it seems like no area is being spared, and we wanted to look and talk about if this is a trend or if we are going to expect this to continue. So we're going to focus on the last few years and the last few decades and how it compares to normal. We've seen quite a few records broken here for precipitation, whether it be snow or rain, or Mississippi River flooding, or floods of record on tributaries to the Mississippi. So let's jump into some of the data that we're seeing historically, both historically and over the last few years. Here's a map of the United States from 1977 through 1997. And this is the average rainfall, the annual mean precipitation across the United States. And our region is usually in the area around 35 inches on a given year. That's melting the snow down and measuring the water that falls. So in 1977 to 1997, this is what this map looked like. Over the last roughly 20 years, we've seen an increase. We've seen an increase in that quote-unquote normal precipitation. And if you just toggle back and forth, you can see that the precipitation, higher precipitation amounts, on average, are moving northward. If we compare what it looked like in the last 20 years compared to 20 to 40 years ago, you can see the footprint over this general area in southeast Minnesota, northeast Iowa, and also southern Wisconsin, where the average rainfall has been over the last 20 years some 5 inches above what we normally expect. So it's really starting to target this area. In 2018, it was a very wet year. Most rainfall was in over the 48-inch amount here on the left-hand side, getting into this lighter red color. And again, our normal is somewhere around 32 to 35 inches in this region. So you can see 2018 was quite a wet year, and it was really bounded by I-90 and I-80 to the south, and roughly just east of Madison, Wisconsin, to about Sioux Falls, Wisconsin. Records were set. It was the wettest year on records along the I-90 corridor for many sites, and it was top 10 for an area of sites that surrounded that axis that ran east-west in 2018. In 2018, that axis was approximately 1.5 to 2 times the annual precipitation that's normally measured. What about 2019? The only change in 2019 we saw was that the wetness had expanded to a regionally wet year compared to 2018, where it was a little bit more localized. When you look at 2019, you can see a lot more light blue on this map. Those are areas that received 1.5 to 2 times their normal precipitation. If you compare that to 2018, it's slightly further north, but some areas you can see between 2018 and 19 overlapped. So overall, 2018 and 2019 have been very wet years. 2019 has been regionally wet. So that rainfall has an effect on soil moisture and groundwater, which also has an effect on how rivers respond and how high rivers will be running. So after 2018, again, you see that I-80 to I-90 corridor where the groundwater, here shown in blue, was anomalously high. So one of the historically highest amounts that we've seen on record since 1948. It basically beat anywhere from 98% to all of the years within the record on this axis. And then we moved into 2019. So after 2019, we saw this expand regionally. So now the upper Midwest, a good portion of it, is in that at least 95 percentile, but getting closer to the 98 percentile for soil moisture and groundwater. So the soils are saturated over the area. What about over the upper Midwest? We're going to look at Michigan, Wisconsin, Iowa, and Minnesota, and look at extreme rainfall events. And these are extreme one-day precipitation events. That is to say that they are in the top 10% for the amount received in one day. And you can see since about 2005, this trend is on the increase. While there is variability year to year, the overall trend is increasing in one-day precipitation extreme events. You can see 2019 was a little bit lower, or an average amount of extreme precipitation events, which means that the rainfall was received just in normal amounts. There weren't extreme rainfalls in 2019 because it was a wet year. So maybe it had more days of rainfall and lighter amounts, but overall the totals were quite wet. Compared to 2018, where we saw quite a few extreme rainfall events, which are in a nutshell, terrain changing events. Let's look at a few more statistics. We're going to look at two climate divisions here, one over north central Wisconsin and one over southwest Wisconsin. And these two representations and comparisons will kind of fit a broader area. So we're going to look at northern Wisconsin, northern Minnesota with this next comparison I'm going to do, and then the area in Iowa, Illinois, and southern Minnesota. So here's the precipitation over the last, approximately 120 years, 125 years for southwest Wisconsin. And I wanted to show the trend. Here's the average, and you can see year-to-year fluctuations. But since about the late 90s, we've been on an increasing trend. And then looking at 2016 to 2019, the trend is really increasing across that area. So we are in a different precipitation regime than we've seen. I've also highlighted the 10-inch above normal line. So the straight line you see here is that average from 1895 to 2019, actually from the 1900 to 2000 average, which is about 33 inches of rain. And then the red line represents 10 inches above normal. So you can see that we're well above that 10 inches above normal for most of the last few years. What about north central Wisconsin? Yes, we're seeing that same trend, that same increasing precipitation, but the magnitude is not quite as high. So here's the 10-inch above normal, and if I just loop back and look at that southwest Wisconsin, which is representative of Iowa and Illinois region as well, you can see that we're well above the 10-inch normal. Where in northern Wisconsin, the trend is increasing, but not quite of the magnitude. What about in southwest Wisconsin, looking at summer days with greater than 1 inch of precipitation? Again, we're looking at a footprint of extreme rainfall. So this is the trend since 1900, and this data only goes through 2018, but you can see that the trend line is increasing, especially over the last few years. In northern Wisconsin and northern Minnesota, we don't quite see that same trend in extreme rainfall greater than 1 inch. Well, let's look at it in plan view now and look at a map of what these extreme rainfall events look like. These are the percentage of days that we typically see in a year with 2 inches or more of rainfall. So this is from 1970 to 1999, and you can see during that period that this area basically received about 1 day per year where they saw sites would receive about 1 day per year where they saw 2 or more inches of rainfall during that pre-2000 30-year period. When we jump to 2005 to 2019 now and look at that same data, we see that the number of days of 2 inches or more has increased or doubled to 2 days per year. Why did I pick 2 inches or more? Those are extreme rainfall days. So what we're looking for is a footprint of how many extreme rainfall events we've had and how that's changing through time. These extreme rainfall events are those that destroy infrastructure and really provide terrain changing changes to our terrain in our area. Let's take one more step forward and look at the period of 2016 to 2019. Here we've now increased to approximately 4 days per year in some of the local areas south of Interstate 90. So again, if we just compare what the trends look like pre-2000 to the last 15 years roughly, and then for the last few years, we've quadrupled or seen 4 times as many extreme rainfall events now over the last years from 2016 to 2019. How have the rivers responded during that time frame? Well, as you can expect, they've increased as well. We're going to look at a river in southwest Wisconsin, the Kickapoo River, and we're just going to look at Lafarge, taking a look at just what the average yearly discharge is, or how much water flows by the Kickapoo River at Lafarge over a given year. And we're going to look at the period from 1939 to 2019. So you can see that there are ebbs, and the river does ebb and flow in its river height through this period with the amount of volume going past the Lafarge river gauge. But look at this trend that we've seen since 2016, an incredibly disturbing trend where we're increasing our flow from the base flow of about 200 through the year to over 500. So that's 2.5 times what it normally would see during that annual time frame. So we are seeing rivers respond. We are seeing rivers flow at higher heights than they normally do as a base flow, which means it's easier to achieve flooding on the Kickapoo River, for example, here. What about Northeast Iowa? We see those same trends in Northeast Iowa with the base flow at on the Cedar River at Charles City increasing over the last several years. That trend is a disturbing trend for flooding. Further north of La Crosse, you see the same trend on the Trempealeau River at Dodge. South central Wisconsin, you see that same trend going as well, although not quite as abrupt as you might see further west, but still a disturbing trend that higher base flow is in the river basin. A little bit further northeast now, you're getting out of that footprint for heavier rainfall over the last several years, and you don't see quite the increase here, although you do see what the 2019 regionally wet footprint gave to the river system, and that is higher base flow. So 2019 was a higher base flow here on the Oconto River at Gillette, and you see that same type of outlier here in 2019. So in summary, what we see is a regional wetter trend with 2016 and 2019 being the most wet. In that same period, some areas have seen about 4 times the amount of extreme rainfall events versus the pre-2000 years. Soil moisture and groundwater are at historical highs in many places. These first 3 bullets lead to more flooding. Rivers have responded with higher base flow and many historical floods over the last several years. What's important here is that higher base flow makes it easier to achieve flooding in river basins. I thank you for your time in viewing this video, and if you have any follow-up questions, please email me at dan.baumgart@noaa.gov. Thank you for your time, and we hope you found this helpful.